Hello, this is our high and low temperature test chamber in our quality control center. Each of the instruments need to do this temperature test before leaving the factory. Now we test the power amplifier performance at 0 and 45 degree. First we set the temperature to 0. We come in and we can see this is our signal generator, and that is our amplifier and power meter. We're using attenuator and the power sensor to get a small signal. We have set the power meter's offset so we can get an accurate output power of the amplifier. It's very cold inside 0 degrees Celsius. We can see we set the frequency at 30 GHz and the output power is -7 dBm. We turn on the output and we can see we can get an output about 180 watt. The instrument has been in the 0 degree Celsius environment for more than half an hour, so the temperature is stable inside. We have tested the instrument in this condition for more than half an hour. Of course, we can increase the input power to get a higher power, but no more than 200 watt at 13 GHz. The power amplifier can work well under cold conditions because it can generate heat itself. So the performance is very similar at the normal temperature at our room, at our lab. The temperature inside the instrument is about 40 degrees Celsius. Actually, we also tested the performance under 12.5 GHz and 13.5 GHz. The performance is very similar as the normal temperature. After test under 0 degrees Celsius, we increased the temperature slowly to 45 degrees Celsius. Yeah, now we go inside and make the test. We go inside. It's 45 degrees Celsius now. We turn on the signal generator's output, and we can see the amplifier can generate 75 watt. We keep increasing the signal generator's output, and we can see the saturated power can be 170 watt at 12 GHz. Even though the declared output power is 100 watt, but we can see the actual output power is much higher.